So now we'll begin sequentially and we'll start with our arithmetic progression. So the first one is arithmetic progression, or simply an AP. And we know that any sequence will be an AP if the difference between any two consecutive terms is constant. So if it is an AP, then A2 minus A1 must be equal to A3 minus A2, must be equal to A4 minus A3, and must be equal to AN minus 1. So all these differences, they must be constant, and this difference D, it is called as common difference. Say for example, this sequence. Now 7 minus 3, 4, 11 minus 7, it is 4, 15 minus 11, 4, 19 minus 15, 4. So all the differences, they are same, they're equal. So it is an arithmetic progression whose first term is 3 and whose common difference is 4. Now we know that in an AP, the difference between two consecutive terms, it is constant. So any term will be given by this previous term plus D. So if we have first term as A, then the next term will be simply A plus D. Now adding D to it, it will be A plus 2D, A plus 3D, and this is how we'll keep adding it. Now this is your first term, this is your second term, this is your third term, this is your fourth term. So for the nth term, we can write this as A plus, for 1 coefficient of D is 0, for 2 coefficient of D is 1, for 3 it is 2, for 4 it is 3. So it will be A plus n minus 1 into D. So this is how we generally write an AP. So any sequence which is of the form A plus D, A plus 2D, and A plus n minus 1D will be an AP whose first term is A and whose common difference is D. So for an AP, its general term or its nth term, it is given by A plus n minus 1 into D. And if it is a finite AP whose last term is the nth term, then we can simply say its last term, say L, it is A plus n minus 1 into D. Now there is this one method which is very useful while solving problems which involve difference of terms of a series or a sequence. And the method is, suppose you have a series, say S, and it is given by A1 plus A2 plus A3 plus AN minus 1 plus AN. What we'll do is we'll write this series again and we'll shift every term by 1. So we'll write A1 here, we'll write A2 here, we'll write AN minus 1 here, and we'll write AN here. Now we'll subtract them. On the left hand side, it'll be 0. Then we'll have this A1 plus A2 minus A1 plus A3 minus A2 up to AN minus 1 and then minus AN, or we can simply write this AN as A1 plus A2 minus A1, A3 minus A2 up to AN minus 1. Now we'll have this another series which we can solve by again using difference or by using some other method. And the thing to note here is this series has actually n minus 1 terms. So this method where we are subtracting a series by shifting it with one term is going to give us this nth term of a sequence or nth term of a series. And we can use it to find nth term of an AP. Suppose we have an AP whose terms are A1, A2, A3, AN, Common difference is D. We can write this sum as A1 plus A2 plus AN. We can again write this sum as A1 plus A2, and here will be this AN minus 1 plus AN. Now if we subtract them, we can write 0. It will be this A1 plus, now this is A2 minus A1, this is A3 minus A2, and this is AN minus 1, and this is minus AN. Now we can write this as AN equals, now this is A1. Now we know that difference between any two successive terms, it is simply D, and this series has n minus 1 terms. So this nth term will be A1 plus n minus 1 into D. So this is another way of writing the nth term of an AP. And in general, we take first term as A. So we generally write this as AN equals A plus n minus 1D for an AP. And now suppose we have A1, A2, A3 and AN. This is an AP with first term A and common difference D. Then we can say it's nth term from the beginning will be given by AM, and there will be A plus m minus 1 into D. And if we look at nth term from the end, so nth term from the end will be equivalent to n minus m plus 1th term from the beginning. So you need to find A n minus m plus 1th term. So this term will be simply A plus n minus m into D. So this mth term from the end, it is A plus n minus m into D. Another way to solve this question could be, you can reverse this series. So we can write this as an minus 1 and A1. Now in this case, since we have reversed it, its common difference will be minus D. Then we have to find nth term of this series from beginning. So we can write this term as an plus m minus 1 into minus D. So it will be this an, which is A plus n minus 1D minus m minus 1D, which again is A plus n minus m into D. Now general term of an AP, it is written as A plus n minus 1 into D, which is linear in n. So if we have any sequence whose terms are linear, then that series will always be an AP. And if you want to write its terms, its first term will be, when the value of n is 1, so it will be alpha plus beta, then 2 alpha plus beta, 3 alpha plus beta, and will go on. So here its first term will be simply alpha plus beta, and its common difference will be 2 alpha plus beta minus alpha plus beta. It will be simply alpha. Now we'll work out sum of first n terms of an AP. Now suppose this sum is S, we can write the series as A plus D, A plus 2D, I'll go all the way up to A plus n minus 1D. Now we'll write the same series in reverse. Now this is A plus n minus 1D. Next one will be A plus n minus 2D. And here will be A. Now if we add the two series, we'll get this as 2S. Now this is 2A plus n minus 1 into D. Now here also, if we add them, a plus a will be 2a, and plus n minus 2d plus d will again be n minus 1d. So each block will be constant and will be 2a plus n minus 1 into d. So we have n such blocks. So we can write this 2s as n into 2a plus n minus 1 into d, or this sum of first n terms will be n by 2 2a plus n minus 1 into d. Another way to write this sum is Sn is n by 2 and a plus n minus 1 into d, and this is nothing but your last term. So sum of n terms will be n by 2 a plus l. We can do this exact same thing in summation form. We know that Sn, it is summation r varies from 1 to n ar, and this ar is nothing but rth term of an AP, which is a plus r minus 1d. We can write this summation in reverse, and it'll be r varies from 1 to n, and this is a plus. Now in place of r, we write n minus r plus 1. So there'll be n minus r plus 1 and then minus 1d. This 1 and 1 will cancel. If we add them both, we'll get 2Sn. It'll be the summation r varies from 1 to n. Now this is 2a plus r minus 1d and n minus rd. Rd will cancel. So we'll get this as n minus 1 into d. And there's no r in this. So this is constant. And summation of constant is simply n into that constant. So there'll be n 2a plus n minus 1d, which is Sn is n by 2 2a plus n minus 1 into d, or simply n by 2 a plus l. Now there is this one interesting result in AP which gives us a beautiful symmetry, and which is if we take rth term from beginning, so this rth term from beginning, it will be say AR, and it will be a plus r minus 1d, and if we take rth term from end, suppose this is some a dash r, and it is given by a plus n minus r into d. Now if we add them both, we can write ar plus a dash r, it will be 2a, and this rd will cancel, n minus 1 into d, which is simply a plus l. So that means sum of terms equidistant from beginning and end. So this is sum of terms equidistant from beginning and end is constant, and it is equal to a plus l. So a1 plus an will be equal to a2 plus an minus 1 will be equal to a3 plus an minus 2, and this symmetry, it is used while solving problems. So in AP we have two symmetries. One of them is symmetry in difference. We know that common difference is same. So we know a2 minus a1 will be same as a3 minus a2 will be same as a4 minus a3. And then we have this symmetry, sum of terms equidistant from beginning and end is constant. That means a1 plus an is same as a2 plus an minus 1, and will be same as a3 plus an minus 2. And this sum will be equal to simply a plus l, where a is your first term and l is your last term. Now, if an AP has odd number of terms, then its middle term will be given by a plus L by 2. Say we have this series A1, A2, A3, An, where n is an odd number. So let n be 2m plus 1. Now we know that its middle term will be n plus 1 by 2th term, and there will be a m plus 1th term, and this a m plus 1th term will be a plus m into d. Now we can have this is 2a plus 2md by 2, and will be a plus 2md by 2. Now a plus 2md is your last term, so it will be equal to a plus L by 2. Then we have arithmetic mean of numbers. Which is written as AM. So if we have n numbers, x1, x2 and xn, then their arithmetic mean, it is given by x1 plus x2 up to xn whole divided by n. So for two numbers, say a and b, arithmetic mean is given by a plus b by 2, and if a is less than b, then we know that arithmetic mean will lie between a and b. So you'll find questions where they'll say you have to insert n AMs between two numbers a and b. So we have two numbers and we have to insert n arithmetic means. Say arithmetic means are given by a1, a2, a3, an, and this is b. Now this resulting sequence will be an arithmetic progression, and total number of terms in this arithmetic progression will be simply n plus 2. So this b is your last term, which is n plus 2th term. So we can write b equals a plus n plus 2 minus 1, which is n plus 1d. So here common difference is b minus a upon n plus 1. So if you have to insert n AMs between a and b, then the common difference is b minus a upon n plus 1. Now this a1 is simply a plus d, a2 is a plus 2d, and any AR is simply a plus r into d, where d is b minus a upon n plus 1. And if we look at arithmetic means of all these AMs, then it is simply a1 plus a2 plus an divided by n. Now this is a plus d, a plus 2d up to a plus nd whole divided by n. Now this is a plus a n times. So this is na, and if we take d common, this is 1 plus 2 plus 3 up to n whole divided by n. Now this is sum of first n natural numbers. So this is na, and this is n plus 1 by 2 whole divided by n. Now this n will cancel. So arithmetic mean of inserted AMs will be 2a plus n plus 1d whole divided by 2, or a plus n plus 1d divided by 2, and this is nothing but b. So arithmetic mean of all the means which are inserted between a and b, it is simply a plus b by 2. Now you'll get many questions on conditions of AP. So if we have A, B and C, they are in AP, then simply their difference, it must be same. So B minus A must be equal to C minus B, or we can simply write twice B equals A plus C. So if A, B, C are an AP, then twice the middle number must be equal to sum of first and last number. And if we have to choose three numbers in AP, we can choose them as A minus D, A, and A plus D. If we have to choose 5 numbers in AP, we can choose them as A minus 2D, A minus D, A plus D, and A plus 2D. And if we have to choose 4 numbers in AP, then we can take them as A minus 3D, A minus D, A plus D, and A plus 3D. Now, in first two cases, common difference is D, but in this third case, common difference is not D but 2D. Or you may simply take it as A plus D, A plus 2D, and A plus 3D, whichever is simple for you. Condition that three numbers are in AP, it is twice B equals A plus C. Or they may give you this condition that AN plus 1 minus AN, this is constant. That is difference of any two consecutive terms, it is constant. Or an equivalent condition could be you are given an AN which is linear in N. So it can be alpha n plus beta. Or they may give you a second difference condition, and which is AN plus 2 minus 2 AN plus 1 plus AN equals 0. That is 2 times AN plus 1 is equal to AN plus 2 plus AN, which again is same condition of an AP. So all these four, they can be used to specify an arithmetic progression. Now there are some properties of an AP. If A1, A2, A3, AN, they are an AP with common difference D, then adding or subtracting same number to all the terms, it will still be an AP. So if we add or subtract some number to all the terms, it will also be an AP with the same common difference D. So this is your first result. Second one is, if we multiply all these terms by same constant, it'll again be an AP. So if we have some constant, say lambda, and we multiply all the terms, lambda A1, lambda A2, lambda AN, then this again will be an AP, and its common difference now will be lambda D. In the same way, if we divide it with some non-zero constant also, so A1 upon lambda, A2 upon lambda, and AN upon lambda, it'll also be an AP with common difference D by lambda. Now, fourth one is, if we have two APs, say A1, A2, A3, AN, and B1, B2, B3, BN, so both of them, they are APs, then the sum or the difference of their terms will also be an AP. So A1 plus minus B1, A2 plus minus B2, and AN plus minus BN will also be an AP. Now, we know that for an AP, nth term is A plus N minus 1D, and its partial sum, it is N by 2 twice A plus N minus 1 into D. Then the result is, if AN is an AP, then SN is quadratic in N. So for an AP, its sum will always be quadratic in N. Second result is, if Sn is quadratic in n, then an is Sn minus 1 will be an AP, and this term will be a linear term. Sometimes we'll get questions where they'll give you a ratio of terms of two APs, and they'll ask you to find ratio of their partial sums or vice versa. So let us take this case when we have two APs, say A1, A2, AN, and B1, B2, BN. Now we are given Sn upon S dash n. Now Sn is sum of n terms of this first AP, and this is sum of n terms of this second AP, and this is some function of n, say fn by gn. Now we know that sum of n terms, it is given by n by 2 twice a1 plus n minus 1 into d, and here will be given by n by 2 twice b plus n minus 1 into d, and this is fn by gn. Now this n by 2 will cancel. We'll divide everything with 2. We can write a1 plus n minus 1 by 2d upon b1 plus n minus 1 by 2d will be fn by gn. Now we need to find ratio of their nth term. So we need to find an upon bn. Now we know that an is a plus n minus 1 into d. So instead of n minus 1 by 2, we need n minus 1. So what we'll do is we'll replace n with 2n minus 1. So if we substitute n with 2n minus 1, we can write this as a1 plus, now this is 2n minus 1 minus 1, a1 plus n minus 1d upon b1 plus n minus 1d, and here also we'll change n with 2n minus 1, and it will be this g 2n minus 1, and this is nothing but your ratio of terms. So from ratio of the given sum, we can find ratio of the given terms. We just need to change n with 2n minus 1. And if we are given ratio of terms, say an upon bn, and this is a plus n minus 1d upon b plus n minus 1d, and this is fn by gn. Now we need ratio of their partial sums, Sn by S dash n, which is n by 2 twice a plus n minus 1d, and n by 2 twice b plus n minus 1d. Now here we'll replace n with n plus 1 by 2. So we can write this as a plus, now it'll be n minus 1 by 2d, and b plus n minus 1 by 2d, and it'll be this f n plus 1 by 2 upon g n plus 1 by 2, and if we multiply everything with n by 2, we can write this as n twice a plus n minus 1d upon n by 2 twice b plus n minus 1d will be equal to f n plus 1 by 2 upon g n plus 1 by 2. So all you need to do is replace n with n plus 1 by 2 to get the ratio of their sums. Now if an is linear, we know that it's an arithmetic progression. So suppose we have an as some alpha n plus beta. Now if we look at an minus an minus 1 will be alpha n plus beta minus alpha n minus 1 plus beta. Now this beta will cancel, alpha n will also cancel. So this is alpha, which is independent of n. That means this difference, it is constant. So if we have a sequence whose term is linear, then that sequence, it will be an AP, and common difference of an AP will be alpha. And here its first term will be given by alpha plus beta. And if an is linear, then clearly Sn will be summation AR, where R varies from 1 to n. So it will be alpha summation R plus summation beta. So it will be this alpha n plus 1 by 2 plus beta n. So it will be a quadratic in n. So for an AP, its general term should be linear, and its partial sum, it will be quadratic in n with no constant term. So if we have a quadratic sum with no constant term, say an square plus bn, then we can write an as sn minus 1. So an will be an square plus bn minus an minus 1 square plus bn minus 1. Now this is a plus b, a minus b. So there will be 2n minus 1 plus b, which again is linear in n, and therefore it will be an AP. So from this condition also, we can find out this is an AP, and here alpha is 2a. So its common difference will be 2a, and its first term will be simply a plus b. Today we'll study sequence and series, and this first question is, let a1, a2 up to an plus 1 be an AP, and let its common difference be d. Now it is defined S1 as sum of the series from a1 to an, S2 is from an plus 1 to a2n, S3 is from a2n plus 1 to a3n. So each of the series contains n terms, and S1 is sum of first n terms, S2 is sum of next n terms, S3 is sum of again next n terms. Now it says prove that the sequence S1, S2, S3, it is an AP whose common difference is n square times the common difference of given progression. Now for this, what we'll do is, we'll write this general series Sk, and we need to find the first of the series. Now if it is S1, last term is an, for S2 it is a2n, for S3 it is a3n. So for Sk minus 1, its last term will be a k minus 1n. Now here its first term will be a k minus 1n plus 1, and then we'll have n terms, and its last term will be a kn. Now this is sum of n terms of an AP, so its sum will be n by 2, 2a, and a here is a k minus 1n plus 1 plus n minus 1 into d, and then we can write sk plus 1. Now here first term will be a kn plus 1. I'll go all the way up to a k plus 1n, and this sum will be n by 2, 2 a kn plus 1 plus n minus 1 into d. Now if this sequence, it is an AP, then difference between any two successive terms must be independent of k. So what we'll do is, we'll find sk plus 1 minus sk, and here n minus 1d will cancel, so we can write this as n by 2, and this is 2a kn plus 1 minus 2a k minus 1n plus 1. Now this 2 and 2 will also cancel, so this is n. Now this is kn plus 1th term, So it will be this a1 plus kn into d, and this is minus, and this is a1 plus k minus 1n into d. Now this a1 and a1 will cancel, and this k and d will also cancel. So this value will be equal to n square d, which is independent of k. Now since it is independent of k, it means this sequence, it is an AP, and this common difference, it is equal to n square into d, where d is the common difference of the given progression, and which is what we need to prove in this question. Now here the question is, let a1, a2, a3, an be an AP, then we need to prove that 1 upon a1 an plus 1 upon a2 an minus 1 plus 1 upon a3 an minus 2 up to 1 upon an a1 is equal to this right hand side. Now we have this one interesting property in arithmetic progression, and the property is arithmetic mean of terms which are equidistant from beginning and the end are equal. So that means a1 plus an by 2, it is equal to a2 plus an minus 1 by 2. It is equal to a3 plus an minus 2 by 2, and it will continue like this. Now we can cancel this 2 also, so we can say sum of these numbers, they will be equal. Now we'll take this series, which is 1 upon a1 an plus 1 upon a2 an minus 1, 1 upon a3 an minus 2 up to 1 upon an a1, and what we'll do is we'll multiply and divide everything with a1 plus an. So we'll write 1 upon a1 plus an, and we'll multiply everything with it. So it is a1 plus an upon a1 an plus a1 plus an upon a2 an minus 1, a1 plus an upon a3 an minus 2, all the way up to a1 plus an upon an a1. Now we can write this is 1 upon a1 plus an, and this is a1 plus an upon a1 an. Now we know that a1 plus an is also equal to a2 plus an minus 1. So we'll replace it here. So we'll write a2 plus an minus 1 upon a2 an minus 1. In the same way, a1 plus an is also equal to a3 plus an minus 2. So it will be a3 plus an minus 2. And this is a3 an minus 2. I'll continue up to a1 plus an upon an a1. Now what we'll do is we'll split these terms. So we can write 1 upon a1 plus an, and here it will be 1 upon an plus 1 upon a1, and here will be 1 upon an minus 1 plus 1 upon a2, 1 upon an minus 2 plus 1 upon a3. I will continue up to 1 upon an plus 1 upon a1. So here we have this series 1 upon a1 plus 1 upon a2 plus 1 upon a3 up to 1 upon an, and again we'll have the series a1 a2 up to an minus 2 an minus 1 an. So we have the series twice, so we can actually write this as 1 upon a1 plus an, and it will be 2 times 1 upon a1 plus 1 upon a2 up to 1 upon an. So this is equal to 2 upon a1 plus an into 1 upon a1 plus 1 upon a2 up to 1 upon an, which is what we need to prove in this question. Now the second question is, show that in an AP, this value, it is equal to right hand side. Now we have this AP, A1, A2, A3, and let its common difference be D. Now we are given the series as A1 square minus A2 square plus A3 square minus A4 square, and it goes all the way up to A 2k minus 1 square minus A 2k square. Now what we'll do is we'll pair these terms taking 2 at a time. So this is A square minus B square, so we can write this as A plus B into A minus B. So there will be A1 plus A2 into A1 minus A2, and this is A3 plus A4 into A3 minus A4. I'll continue up to A2k minus 1 plus A2k into A2k minus 1 minus A2k. Now we know that in an AP, difference between any two successive terms, it is either D or minus D. Since it is A1 minus A2, so it will be this minus D. It will also be minus D. And in the same way, it is also minus D. So we'll take this minus D common, and then we'll have A1 plus A2 plus A3 plus A4 up to A2k, which is sum of first 2k terms of an AP. Now this is minus D and this is n by 2. So it will be 2k by 2 and A plus L, which is A1 plus A2k. Now this 2 and 2 will cancel. So it is equal to minus D into k. This is A1 plus A2k. Now we also know that in an AP, this A2k will be equal to A1 plus 2k minus 1 into D. So we can write this D as A2k minus A1 upon 2k minus 1. So we'll put it here. So if we put it here, we'll get minus, and this is A2k minus A1 upon 2k minus 1 into k into A1 plus A2k. Now we'll take this minus sign here, then it will be A plus B into A minus B, which is k upon 2k minus 1 into A1 square minus A2k square, which is what we need to prove in this question. Now here the question is, if the sum of m terms of an AP is equal to sum of either the next n terms or the next p terms, then prove that 1 upon m plus n into 1 upon m minus 1 upon p will be equal to m plus p into 1 upon m minus 1 upon n, where n is unequal to p. So what we are given is sum of m terms is equal to sum of next n terms. Now we can write sum of next n terms as sum of m plus n minus sum of n terms. So it will give us the sum of next n terms. So we can write 2sm will be equal to s m plus n, and we are given that it is also equal to sum of next p terms. So another condition which we have here is 2sm will be equal to s m plus p, where n is unequal to p. Now we'll simplify this first condition. So we can write 2, and this is m by 2 2a plus m minus 1 into d, and it will be equal to m plus n by 2 2a plus m plus n minus 1 into d. Now this 2 and 2 will cancel. Now what we'll also do is we'll let this 2a plus m minus 1 d as sum x. So we can write 2mx will be equal to m plus n, and here will be this 2a plus m minus 1 d is x plus n into d. Now we'll take this x on the left hand side. We can write m minus n into x, and that will be equal to m plus n into nd, or we can simply write x upon d will be equal to n into m plus n upon m minus n. Now similarly we can write it for this equation, and from here we get this x upon d as p into m plus p upon m minus p. Now we equate these two, we'll get n into m plus n upon m minus n, and that will be equal to p into m plus p upon m minus p. Now we can rearrange this as m plus n into m minus p into n, and that will be equal to p into m plus p into m minus n. Now we'll divide everything with m and p, and we'll divide it with these two terms. So we'll write m plus n. Now this n will cancel and it will be 1 upon p minus 1 upon m, and here will be this m plus p, and it will be 1 upon n minus 1 upon n, which is what we need to prove in this question. Now the question is, let there be n APs beginning with unity. So for each of the APs, first term is 1, and their common differences are 1, 2, 3 up to m. So their common differences are I. Show that sum of their nth term is m by 2 into mn minus m plus n plus 1. So if we write nth term for this ith series, it will be ai plus n minus 1 into I. So it will be 1 plus n minus 1 into I. Now we need to find sum of all these terms where I varies from 1 to m. Now it will be this summation. I varies from 1 to m, 1 plus n minus 1 into I. Now summation 1 is m, and this is n minus 1, and summation I is m into m plus 1 by 2. Now what we'll do is we'll take m by 2 common. So if we take m by 2 common, we'll get this as 2 plus n minus 1 into m plus 1, and this is m by 2, and here will be this mn plus n minus m plus 1, which is what we need to prove in this question. Now the question is, a series of natural numbers is divided into groups. In the first group we have 1, in the second group we have 2, 3, 4, in the third group we have 5, 6, 7, 8 and 9, and so on. We need to find sum of the numbers in the nth group. So we are talking about nth group. Now in first group we have 1 number, in second group we have 3 numbers, in third group we have 5 numbers. So in nth group, we'll have a plus n minus 1 into d, that is 2n minus 1 numbers. So we'll have 2n minus 1 numbers. Now we know that in each group numbers are in AP whose common difference is 1. So we have common difference of 1. We need to find this first term. Now there are many ways to find this first term. Now what we can see is, here this is 1. For the second one it is 2. For this third one it is 9. So this is 1 square. This is 2 square. For the third it is 3 square. For this n minus 1th group, last number will be n minus 1 square. So here this first term, it will be n minus 1 plus 1th term. So for this nth group, A is n minus 1 square plus 1. Common difference is 1. And number of terms, it is 2n minus 1. We just need to find its sum. So sum of these numbers will be n by 2. So it will be 2n minus 1 by 2. And then a plus l. So it will be this n minus 1 square plus 1 plus, and we know that here last term will be n square. So it will be simply n square. So we can write this as 2n minus 1 by 2, and here will be 2n square minus 2n plus 2, which will cancel. So it will be this 2n minus 1 into n square minus n plus 1. Now we have to express it in the form n minus 1 cube plus n cube. So what we'll do is we'll write this as n plus n minus 1, and here we'll subtract n and add n. So there will be n minus 1 whole square plus n. Now we multiply them, we can write n into n minus 1 square plus n square plus n minus 1 cube plus n into n minus 1. So it will be this n cube plus n minus 2n square plus n square plus n minus 1 cube plus n square minus n. Now this n square and 2n square will cancel, n and n will also cancel. So it will be this n minus 1 cube plus n cube, and that is what we need to prove in this question. Now for this question, another way to find this first term is, now in this first group there is only one term. So this next term is this 1 plus 2. Now here we have 1 plus 3, 4 terms, and this is 4 plus 1, fifth term. Now here we have 1 plus 3 plus 5, 9, and here will be this 10. So this first term, it will be 1 plus 3 plus 5 up to now till n minus 1th group. So we'll have n minus 1 terms plus 1. Now we know that sum of first n odd natural numbers is n square. Here we have n minus 1 terms. So there will be n minus 1 whole square plus 1. So that is another way of finding this first term, which again is n minus 1 whole square plus 1. Now here it says the real numbers x1, x2 and x3 satisfying the equation x cube minus x square plus beta x plus gamma equals 0. They are in AP. Then find the intervals in which beta and gamma lies. Now suppose these three roots x1, x2 and x3 which are in AP, they are a minus d, a and a plus d. Now if we write S1, which is sum of roots, we can write 3a equals 1, or the value of a is 1 by 3. Now we write S2, which is sum of roots taken 2 at a time. So it will be this a into a minus d plus a into a plus d plus a minus d into a plus d, and that will be equal to beta. Now here AD will cancel, so we'll get this as 2 times a square plus a square minus d square. It is equal to beta, or we can write d square is 3a square minus beta. Now a is 1 by 3, so we'll get this as 1 by 3 minus beta. Now d square, it should be greater than or equal to 0. So from here we'll get this condition that value of beta must be less than or equal to 1 by 3. Now we need to find a range of gamma. Now for gamma, we write S3. Now S3 is product of roots. So this is a minus d into a plus d, and it will be equal to minus gamma. Now this is a into a square minus d square, and this is minus gamma. Now a is 1 by 3, so it will be this 1 by 3, and this is 1 by 9 minus d square, and this is minus gamma. We can write d square as 1 by 9 plus 3 gamma. Now again d square, it should be greater than or equal to 0. So from here we get value of gamma, it should be greater than or equal to minus 1 by 27. So we have range of beta and we also have a range of gamma, and that is the answer to this question. Now here the question is, for an AP, mth term is 1 by n and nth term is 1 by n. We will find its mth term. It's a very simple question. Now mth term is a plus m minus 1 into d, and it is 1 by n, and nth term is a plus
n minus 1 into d, it is 1 by m. Now we subtract second from first, we get m minus n into d will be equal to 1 by n minus 1 by m, which is m minus n upon mn. And since m and n, they are unequal, we'll get d as 1 by mn. Now if we put d as 1 by mn, we get a plus m minus 1 upon mn, and it is equal to 1 by m. From here we get a also as 1 by mn. And once we have a and d, we can write its mnth term. Its mnth term will be a plus mn minus 1 into d. Now a is 1 by mn, so it will be this 1 by mn plus mn minus 1, and this d is also 1 by mn. So it will be this mn by mn, which is 1. So answer to this question is 1, which is your option C. Now the question is, let P and Q be the roots of equation x square minus 2x plus a. So we have this equation x square minus 2x plus a equals 0, and here roots are P and Q, and R and S are the roots of the equation x square minus 18x plus b equals 0, and here roots are R and S. Now it says P is less than Q, and it is less than R, and it is less than S, and they are in AP. We need to find the value of capital A and capital B. Now suppose the roots are P, P plus D, P plus 2D, and P plus 3D, where D is greater than 0, as it is an increasing AP. Now for this first equation, we can write sum of roots. So we can write 2p plus d, it is equal to 2, and product of roots, so there will be p into p plus d will be equal to a. And for the second equation, again we can write sum of roots, so it will be this 2p plus 5d will be equal to 18, and product of roots p plus 2d into p plus 3d, that will be b. Now from these two equations, we can find the value of p and d. Now if we subtract first from second, we can write 4d equals 16. That means value of d is 4, and if we put d as 4, we'll get value of p as minus 1. So we have p as minus 1 and d as 4. Now the four terms of AP are minus 1, minus 1 plus 4, 3, 3 plus 4, 7, 7 plus 4, 11. Now A is nothing but product of roots. So this is minus 3, and B is product of roots of this equation, and that will be 77. So value of A is minus 3 and value of B is 77, and that is the answer to this question. Now here the question is, find the condition that roots of the equation x cube minus px square plus qx minus r equals to 0, they are in AP, and hence solve this given equation. Now suppose roots of this equation are a minus d, a, and a plus d. Now if we write S1, which is sum of roots alpha plus beta plus gamma, we'll get 3a equals p, or a is p by 3. Now since a is root of this equation, it will satisfy this equation, so we can write p by 3 cube minus p by 3 square plus q into p by 3 minus r equals 0. Now we can write this as p cube minus 3p cube plus 9p cube minus 27r equals 0, or we can write this as 2p cube minus 9p cube plus 27r equals 0. So if roots are in AP, then the condition is 2p cube minus 9p cube plus 27r must be equal to 0. Now we are given this quadratic equation, which is x cube minus 12x square plus 39x minus 28 equals 0. Now we compare it with this given equation. We can write p as 12, q as 39, and then r as 28. Now if we calculate 2p cube minus 9p cube plus 27r, there will be 2 into 12 cube minus 9, 12 into 39 plus 27 into 28, and if we'll solve this, we'll find it is equal to 0. So that means roots of this equation, they are in AP. Now if the roots are in AP, let the roots be a minus d, a, and a plus d. Now we can write S1, which is sum of all the roots. So it will be this 3a, and 3a equals 12. So value of a is 4. And then we can write S3, that is product of all the roots, and it will be this a into a square minus d square, and that will be equal to 28. Now we put a as 4. So it will be this 4, and then 16 minus d square equals 28. This is 7. So d square is 9. That is value of d is plus or minus 3. So whether we take d as plus 3 or minus 3, we'll end up getting the same result. So a minus d will be 1, a is 4, and a plus d is 7. So the three roots of this equation are 1, 4, and 7. Now here the question is, interior angle of a polygon are in AP. So we have a polygon whose interior angles, they are in AP. The smallest angle is 120 degrees. So A is 120 degrees and their common difference is 5 degrees. So D is 5 degrees. Find the number of sides of polygon. So we have to find number of sides. Now we know that sum of interior angles of a polygon, it is given by n minus 2 into 180. And it's simple to work out. So we'll have n triangles. Sum of all the angles of a triangle will be n into 180, and from this sum we'll subtract all these angles which are at the vertex or which are at the center of this polygon. So it will be minus 360. So we can write this as n minus 2 into 180 degrees. So we have first term, common difference, and sum of all the angles. We should be able to find the value of n. So sum of all the angles will be n by 2, 2a plus n minus 1 into d, and that will be equal to n minus 2 into 180 degree. Now we can cancel 5 here. So this is 5, 24, and this is 36. Now this is n, and here it is n 48 minus 1, n plus 47, and here will be this n minus 2 into 72. So we'll write n square plus 47n, it is equal to 72n minus 144. So it will be this n square minus 47 minus 72. 25n plus 144 equals 0. So this is simply n minus 16 and n minus 9 equals 0. So value of n is either 16 or value of n is 9 for this sum to be equal to n minus 2 into 180 degrees. Now here, before jumping on to any conclusion, we must also see any angle must be less than 180 degrees. It should be convex polygon. So that means any angle or any an which is a plus n minus 1 into d should be less than
180 degrees. So if we divide it with 5, we can write 24 plus n minus 1. It should be less than 36, or n should be less than 13. So the only answer that we have to accept in this question is n equals 9. So answer is n equals to 9, and we have to discard n equals 16. Now this second question is similar to the first one. It says interior angle of a convex polygon form an AP whose common difference is 4. So it is an AP whose common difference is 4 degrees and its largest angle is 172 degrees. We have to find number of sides. Now again in this, sum of all the angles will be equal to n minus 2 into 180. Now in this case, because we are not given first term, so what we'll do is we'll reverse this AP starting from 172 and we'll take its common difference as minus 4 degrees. So it'll be this n by 2 and then 2a, which is 2 into 172 degrees plus n minus 1 into minus 4 degrees. Now here it will be n minus 2 into 180, that will be equal to n into, now this is 172 plus 2, 174 minus 2n. So we can write this as 2n square and then 180n minus 174n, that will be plus 6n minus 2 into 180 equals 0. Now we'll divide everything with 2. So it will be this n square plus 3n minus 180 equals 0, which is n plus 15 into n minus 12 equals 0. Now n, it cannot be negative. So the only value of n we get here is 12. So here the answer is value of n is 12. Now here the question is, if there are n AMs which are inserted between 1 and 31. So between 1 and 31, n AMs are inserted. Now it says such that 7th mean upon n minus 1th mean, it is equal to 5 by 9. Find the value of n. Now if we find its common difference, it will be simply b minus a, which is 30 upon n plus 1. So this common difference will be 30 upon n plus 1. Now this a7 will be a plus 70, which is 1 plus 210 upon n plus 1, and there will be n plus 211 upon n plus 1. So that's your a7. And then we need to find a n minus 1. So it will be this 1 plus n minus 1 into d will be 1 plus n minus 1 into 30 n plus 1, which is 31n minus 29 upon n plus 1. Now if we take the ratio a7 upon a n minus 1, here n plus 1 will cancel, we get n plus 211 upon 31n minus 29 as 5 by 9. Now we can write 9n plus 1899 will be equal to 155n minus 145. Now this is 146n equals 1899 plus 145, which is 2044. So from here we get the value of n as 14. So basically 14 AMs were inserted between 1 and 31. Now it says sum of n terms of two arithmetic series are in the ratio 7n plus 1 upon 4n plus 27. Find the ratio of their nth term. Now we are given the ratio of their sum of n terms. So let it be
Sn and S dash n. Now sum of n terms for this first series be n by 2, and this is 2a plus n minus 1 into d, and for the second series it will be this n by 2 and then 2a dash plus n minus 1 into d dash, and it is equal to 7n plus 1 upon 4n plus 27. Now this n by 2 will cancel. Now what we'll also do is, on the left hand side we'll divide everything with 2. So we can write a plus n minus 1 by 2 into d upon a dash plus n minus 1 by 2 into d dash, it is equal to 7n plus 1 upon 4n plus 27. Now we have to find ratio of their nth term, and we know that ratio of their nth term will be Tn upon T dash n, and will be a plus n minus 1d upon a dash plus n minus 1 into d dash. So basically on the left hand side we need n minus 1 and not n minus 1 by 2. So what we'll do is we'll replace n minus 1 by 2 with, suppose, n minus 1. Now here we can write n equals 2n minus 1. So what we'll do is we'll replace n with 2n minus 1. Now we replace n with 2n minus 1, we can write a, and here will be n minus 1d upon a dash plus n dash minus 1 into d, and here also we'll replace n with 2n minus 1, so there will be 7 into 2n minus 1 plus 1 upon 4 2n minus 1 plus 27. Now this is 14n minus 6 upon, and here will be 8n plus 23. Now we can change this capital N into small n. We can write a plus n minus 1 into d upon a dash plus n minus 1 into d dash, which is basically ratio of their nth term will be equal to 14n minus 6 upon 8n plus 23. So basically the shortcut is, if you have Sn upon S dash n as some function of n, Fn, then ratio of their nth term Tn upon T dash n will be simply F 2n minus 1. You just need to replace n with 2n minus 1. Now here the question is, the first and last term of an AP are a and b. So we have an AP whose first term is a and last term is b, and there are altogether 2n plus 1 terms. It says a new series is formed by multiplying each of the first 2n elements by the next term. Show that sum of the new series is this value. Now we know that this b is 2n plus 1th term. This b will be a plus 2n into d. So common difference of this AP will be b minus a upon 2n, and that's our first result. Now what they have asked for is this summation AR into AR plus 1, where R varies from 1 to 2n. We need to find this sum, A1 into A2 plus A2 into A3 up to A2n into A2n plus 1. Now we know that its R term is A plus R minus 1 into D, and its R plus 1th term is A plus R into D. Now if we simplify this, we can write this as this summation R varies from 1 to 2n, and here will be this A square plus R square minus R into D square, and then we'll have this AD into 2R minus 1. Now summation A square is nothing but A square into 2n plus this is D square, and then summation R square. Summation R square is 2n plus 1, 4n plus 1 whole divided by 6, and then minus summation r, which is 2n plus 1 by 2 and plus a into d, and 2r minus 1 is sum of odd numbers from 1 to 2n, which is simply 2n square. Now we can simplify it. We can write this as a square into 2n plus d square, and here we'll take 2n plus 1 by 6 common, then we get 4n plus 1 minus 3 and plus ad into 2n square. Now we'll substitute the value of d, and we know that d is b minus a upon 2n. So now it will be this s, and this is 2na square, and this is b minus a whole square upon 2n square, and 2n square will be 4n square 2n into 2n plus 1 by 6 into 4n minus 2 and plus a, and this is b minus a upon 2n into 2n square. Now here 2n and 2n will cancel, so we'll get here 2n, and this 2 will also cancel, so here will be this 2n minus 1. So we can write this as 2na square plus b minus a whole square into 4n square minus 1 upon 6n, and here also 2n will cancel, so you'll get 2n ab minus a square. Now 2n a square will also cancel, so this sum will be b square plus a square into 4n square minus 1 and then minus 2ab, so there will be minus 2ab into 4n square minus 1, and this is plus 12n square ab whole divided by 6n. So we can write this sum as b square plus a square into 4n square minus 1, and we'll take 2ab common, so it will be this 6n square minus 4n square, which is 2n square plus 1 whole divided by 6n, which is what we need to prove in this question. Now here the question is, in an AP of which a is the first term, and if sum of the first p terms is equal to 0, so it says sum of first p terms is equal to 0, then show that sum of next q terms is this value. So we have to find sum of next q terms. So what we can do is we can find sp plus q minus sp to find sum of next q terms. Now essentially sp is 0, so it is nothing but it is sp plus q. Now if sp is 0, we can write p by 2 2a plus p minus 1 into d, it should be 0, or 2a plus p minus 1 into d, it will be 0. Now sp plus q is p plus q by 2, will be 2a plus p plus q minus 1 into d, which we are going to write as p plus q by 2, and this is 2a plus p minus 1 d plus qd. Now this value, it is 0, so it will be this p plus q by 2 into qd. Now this d is nothing but it is minus 2a upon p minus 1. So we can write this as p plus q by 2 into q, and this is minus 2a upon p minus 1. Now this 2 and 2 will cancel, so it will be this minus a p plus q into q upon p minus 1, which is what we need to prove in this question. Now here the question is, this sequence a1, a2, a3 up to a98, it satisfies this relation, which is an plus 1 minus an, it is equal to 1. That means it is an AP because successive difference is constant and it is equal to 1. So value of d is 1, and say its sum is equal to 4949. So sum of these 98 terms, it is 4949. Now we know that sum of 98 terms will be 98 by 2, 2a plus n minus 1. So there will be 97 and d is 1, and it is equal to 4949. Now this is 101 and 2a is 4. So basically value of a is 2. So this series is 2, 3, 4 up to 99. That says we have to evaluate this series where k varies from 1 to 49, and this is a to k. That means we are talking about second term, fourth term, so it will be this 3, 5 up to 99, and what we'll do is we'll add 1 and subtract 1. Now we know that this is nothing but this is equal to n square, and n here is from 1 to 49, and we have added one more term, so there will be 50 square. So there will be 50 square minus 1, so it is 49 into 51, which is 2499, and that is the answer to this question. The fourth power of the common difference of an AP with integer entries added to the product of any 4 consecutive terms of it prove that the resulting sum is square of an integer. So we need to find 4 consecutive terms of an AP. Let these terms be a minus 3d, a minus d, a plus d, and a plus 3d, and for this AP common difference is 2d. Now it says product of any 4 consecutive terms. So if we multiply them, it will be a plus b into a minus b. We can write a square minus d square into a square minus 9d square, and then we are going to add fourth power of common difference. So fourth power of common difference will be 2d to the power 4. Now we can write this as a to the power 4, and this is minus 10 d square a square plus 9d to the power 4 plus 16d to the power 4, which is a to the power 4 minus 10 a square d square plus 25d to the power 4, which is a square minus 5d square whole square, which is sum of the squares of an integer. Now the question is, if the sum of first 2 n terms of an AP is equal to sum of first n terms of this second AP, then the value of n is. Now sum of first 2 n terms, so it will be this 2n by 2 and then 2a plus 2n minus 1, and common difference is 3, will be equal to n by 2 2a plus n minus 1, and here common difference is 2. Now this 2 and 2 will cancel, here this 2 and 2 will cancel, and this n will also cancel, so we'll get this as 6n plus 1, it is equal to n plus 56, or 5n equals 55, that is value of n is 11, and that's your option C. Write the questions. Find the coefficient of x to the power 8 in this polynomial, which is x minus 1, x minus 2, x minus 3 up to x minus 10. Now there are 10 terms in the expression, so highest power of x will be x to the power 10. If someone is going to ask you to find coefficient of x to the power 10, it is simple, it will be simply 1. What about if we need to find coefficient of x to the power 9? Now we get x to the power 9 when these 9 x's from these 9 brackets, they get multiplied to itself and then this x to the power 9 will get multiplied to -1. So we'll get -1 x to the power 9. We'll get x to the power 9 when all these remaining x to the power 9 gets multiplied with -2. So it will be -2 x to the power 9. It will continue up to -10 x to the power 9. So coefficient of x to the power 9 will be simply -1, -2, -3 up to -10. There will be -1 and n plus 1 by 2, and there will be -55. Now in this question, they have not asked for x to the power 10 or x to the power 9. What they are asking for is x to the power 8. So we need to find coefficient of x to the power 8. Now we'll get x to the power 8 when 8 of the x's get multiplied to themselves, and then these x to the power 8, it gets multiplied with constant term of 2 brackets. So it will be 1 into 2, 1 into 3, 1 into 10, and will continue up to 9 into 10. So basically it is product of all the terms from 1 to 10 taken 2 at a time. Now we know that 1 plus 2 plus 3 up to 10 whole square, it is n plus 1 by 2 whole square. Now we can write this as a square plus b square plus 10 square plus 2 times, and then 2ab, bc, ac, all these terms. So basically here what we'll get is this series which we are looking for, and let the series be s. So it will be this 2s, and it will be equal to 55 square. Now this is n plus 1 to n plus 1 by 6 plus 2s, and it will be equal to 55 square. So we get 2s is 2640, or value of s is 1320. So coefficient of x to the power 8 will be 1320, and that's your option B.
Now here the question is, three numbers in AP with common difference D are removed from first n natural numbers, and the average of remaining numbers is found to be 43 by 4. Then ordered pair n and D can be. So we have first n natural numbers 1, 2, 3 up to n, and from these n numbers we have removed three numbers which are in AP, and suppose they are a minus d, a, and a plus d. It says the average of remaining numbers is found to be 43 by 4. Now we know that sum of all these numbers, it is n plus 1 by 2 minus sum of these three numbers, which is 3a, and for their average we have to divide them with n minus 3, and this average, it is equal to 43 by 4. We can write this as n square plus n minus 6a upon 2n minus 3, and it is equal to 43 by 4. Now this 2 will cancel. We can write this as 2n square plus 2n minus 12a, and this is 43n minus 129. So we can write this as 2n square minus 41n plus 129 minus 12a equals 0. Now we can write this a as 2n square minus 41n plus 129 divided by 12. Now this a, it has to be an integer. Now we can also write this as a. We'll take this n common, and then it will be 2n minus 41 plus 9, and then we write this as 120. So it will be this whole divided by 12 and plus 10. It should be an integer. Now we need to find value of n. for which this a, it is an integer. Because a minus d, a and a plus d, they come from natural numbers. So this a, it has to be a natural number. Now there are two values of n given in the question. Either n can take the value 19 or 23. So first we'll check for n equals 19. Now if we put n as 19, it will be this 19 and then this is 38 minus 41. So that will be minus 3 plus 9 divided by 12 plus 10. Now we can cancel 3. So that will be minus 19 plus 3. Minus 16. Minus 16 by 4 is minus 4 plus 10. So value of a is 6. So one of the solution is when the value of n is 19 and when n is 19, value of a is 6. Now since we have a minus d, that means value of d, it should be less than 6. So for 19, we can choose any value of d which is less than 6. So one of the option is 19.5, another option is 19.2. We cannot choose 19.8. Now what if n is 23? If we put n as 23, we'll get this as 23 and this is 46 minus 41, 5 plus 9 divided by 12 plus 10, which is not an integer. So n is equal to 23 is not a solution. So the correct options are A and B. Now the question is 4 different integers form an increasing AP. One of these numbers is equal to sum of squares of other 3 numbers. Then which of the following is correct? Now suppose the numbers are a minus d, a plus d and a plus 2d, where d is greater than 0 since it is an increasing AP. And the reason we have taken this as a minus d, a and a plus d, because we have to use sum of squares of other 3 numbers. So we are given that a plus 2d is equal to a minus d square plus a square plus a plus d whole square. Now this is a plus 2d. Now this is a square plus a square plus a square. There will be 3a square and then plus 2d square minus 2ad plus 2ad will cancel. So we can write this as 2d square minus 2d plus 3a square minus a equals 0. Now if we solve for d, we can write d equals 2 plus or minus under root of b square, which is 4, and then minus 8, 3a square minus a whole divided by 4. Now we can cancel 2. We can write d 1 plus minus under root of 1 minus 6a square plus 2a whole divided by 2. In the question, we need integers. That means this d, it must be an integer, and this 1 minus 6a square plus 2a square, it must be greater than 0 and it must also be a perfect square. Now if we simplify this, we can write 6a square minus 2a minus 1 is less than 0. The critical points are 2 plus minus under root of 4 plus 24 whole divided by 12, and this is 1 plus minus under root 7 divided by 6. So here we have two values of a, 1 minus root 7 by 6 and 1 plus under root 7 by 6. This is plus, minus and plus. So from here, the only integral value of a possible in this region is a equals 0. And if we put a equals 0, we'll get value of d as 1. Once we have the value of a and d, we can write all the 4 numbers. So the 4 numbers are minus 1, 0, 1 and 2, and product of all numbers is simply 0. Now what is the sum of all these numbers? Sum of these 4 numbers is simply 2. And what is the common difference of four numbers? We know that value of D here is 1, and that's your option A. So the correct options are C, D, and A. Now here the question is, natural numbers are divided into sets 1, 2, 3, 4, 5, 6. So in the first set, we have this element 1. In the second set, we have this element 2. In the third set, we have this element 4. Now, in the first set, we have one element. Now, in these two sets, we have three elements. In first three sets, we have six elements. In the fourth set, which you can write 7, 8, 9, 10, we have 10 elements. So last element of any set is going to coincide with number of elements from 1 to that number. So if we talk about this n minus 1 set, then this last element in n minus 1 set, it will be sum of all the numbers in all the sets till this set. So it will be 1 plus 2 plus 3 up to n minus 1. So it will be n minus 1 by 2. So first element of this nth set, it will be n minus 1 by 2 plus 1, or simply n square minus n plus 2 whole divided by 2. And last element in this set n, which is the nth element, will be n plus 1 by 2, and number of elements will be simply n. That says sum of element in any set. Now first we need to find sum of element in any set. So sum of element in this nth set will be simply n by 2 and then a plus l. Now a plus l will be n square minus n plus 2 by 2 plus n square plus n by 2. Now this n and n will cancel. Now this is 2n square plus 2. So we'll get this as n by 2 into n square plus 1. Now S50 will be simply 25, and this is 2501, which is 62525. And that's your option B. Now the next question is last element in 2007th set. Now last element in nth set, it is n plus 1 by 2. So last element in 2007 set, it will be 2007 into n plus 1 by 2. So there will be 2008 whole divided by 2. So it is 1004, and this is 2015 028, and that's your option A. And finally, it says the average of middle two elements of 2008 set is lambda. Now we know that in any set we have numbers in AP, and in an AP the average of numbers equidistant from beginning and end, they are same. So average of middle two elements of 2008 set will be same as average of its first element and its last element. Now if we add them, this n square will cancel, so this average will be simply n square plus 1, this whole divided by 2. Now we need this average for n equals 2008, so there will be 2008 whole square plus 1 divided by 2, and we need its integral value. Now this is 2016032.5, so its integral value will be 2016032, and that's your option C. Now here the question is, if A1, A2, A3, A2n plus 1 are in AP, then we need to simplify this series. Now we know that if A1, A2, A2n, A2n plus 1, they are in AP, then in that case, A1 plus A2n plus 1 by 2 is equal to A2 plus A2n by 2. That is, arithmetic mean of terms equidistant from beginning and end, they are all equal, and since in this AP there are odd number of terms, it will be equal to its middle term, and its middle term will be when the value of r is 2n plus 1 plus 1 by 2. So this is equal to a n plus 1. So all these denominator in this expression, they reduce to 2a n plus 1. So we can write this series as 1 upon 2a n plus 1, and this is a2n plus 1 minus a1, a2n minus a2, an plus 2 minus an. Now this is 1 upon 2 an plus 1. Now a2n plus 1 is a1 plus 2n into d minus a1. This a1 and a1 will cancel. Now a2n is a plus 2n minus 1d minus a2 is a1 minus d. Now here a1 will cancel, so we'll get this as 2n minus 2d, and we'll continue, and here it will be 2d. Now we can write this as 1 upon 2 an plus 1, this is 2n, this is 2 n minus 1, and goes all the way up to 2 into this common difference d. Now we can cancel this 2. Now this is nothing but sum of first n natural numbers. So it is n plus 1 by 2 an plus 1 into d, where d is common difference. So we can write this as n plus 1 by 2 an plus 1 into a2 minus a1, and that's your option A. Now in sequence and series, we have this one shortcut which is very handy when it comes to problems involving terms common to the two or more given arithmetic progressions. So we'll be given two APs. Suppose we have this first AP which is characterized by A1 plus D1 and so on, and we have this second AP which is A2 plus D2, A2 plus 2D2. Then the terms which are common to both the APs, they'll also form an AP whose common difference is given by LCM of D1, D2. So the terms which are common to both the APs, they'll also form an AP, and that common difference will be LCM of common difference of the two given APs. And by observation or by using initial few values, we can calculate this A, which is first common term. And once we have first common term and common difference, then we can solve whatever is desired in the given question. So let us take one example. Now here the question is the 10th common term between the two series. So we are given two series. First series is 3 plus 7 plus 11. It is an AP, and in this AP common difference is 4, and then we have this second AP which is 1, 6, 11. So it is also an AP, and its common difference is given by 5. Now the terms which are common to both the series, they'll form an AP whose common difference will be given by LCM of D1, D2. So it will be LCM of 5 and 4, and LCM of 5 and 4 is 20. And from observation, we know that its first common term is 11. So we have first common term, and we also have its common difference. We need 10th common term. So the 10th common term between the two series will be 10th term of this AP, which is A plus n minus 1 into D. So this is 180 plus 11, and that will be 191, and that's your option A. Let us take another example. And this question, it says the largest term common to these two sequences, both they are an AP containing 100 terms. So this first AP, it is 1, 11, 21, 31 up to 100 terms. So that's your first AP, and then our second AP is 31, 36, 41, 46 up to 100 terms. Now terms common to both the series 31, 41, they'll also form an AP whose common difference is LCM of common difference of the two APs. Now common difference of first AP is 10 and common difference of second AP is 5. So we need to find LCM of 10 and 5. So it will be 10. Here in this case, value of D is 10, and again just by observation we know that first common term is 31. So this AP of common terms will have first term is 31 and common difference is 10. Now its general term Tn will be given by A plus n minus 1 into D. So it will be 31 plus n minus 1 into 10. Now we need largest term common to the sequence. Now largest term common to the sequence will be less than or equal to minimum of last term of the two sequences. Now basically minimum of the two sequences will be in this second series. So this Tn, it should be less than or equal to last term of this second sequence, and which is 31 plus 100 minus 1 into D, which is 5. So this 31 will cancel. So we'll get n minus 1 into 10 will be less than equal to 99 into 5, or this n will be less than or equal to 50.5. So the highest value of n in this case will be 50. So the largest term which is common to both the series will be 31 plus 50 minus 1 into D. So this is 31 plus 490, which is 521, and that's your option D. Now let us take another example, and this question was asked in JEE Advanced 2019, and the question was, we are given 3 APs. So we have this first AP whose first term is 1 and common difference 3. Then we have this second AP whose first term is 2, common difference 5, and then we are given this third AP whose first term is 3 and common difference is 7. It says we need to find intersection of these 3 APs. Basically we need to find terms which are common to the 3 APs. So terms which are common to all the 3 arithmetic progressions, and we already know that terms which are common to APs will also form an AP, and in this case we need to find the value of A and D, where A is first common term and D is their common difference. Now D is simple, common difference of the common terms of the three series is basically LCM of common difference of three APs. So it will be LCM of 3, 5 and 7. Now we know that LCM of 3, 5 and 7 will be 105. So common difference of this AP of common terms will be 105. Now we need to find A, which is first common term. Now what we'll do is, in order to find A, we look at general terms of these three APs. Now general term of this first AP, we can write this as 1 plus n minus 1 into 3, or we can simply write this as 1 plus 3p, and since we need common terms, it should be equal to general term of this second AP, which is 2 plus 5q, and it should be equal to general term of this third AP, which is 3 plus 7r. Now what we'll do is, first we'll find terms which are common to these two series. Now for these two series, we can write q equals 1 plus 7r upon 5. Now what we'll do is, we'll put the value of r and we'll find the smallest value of r, for which this q, it is an integer. If we put r as 1, it is not an integer, but if we put r as 2, we'll get q as 3. Now this is 15 plus 2, 17. So first common term of these two APs, it is 17. Now we know that common difference of these two series are 5 and 7. So common difference of terms which are common to these two series will have common difference, which is LCM of 5 and 7, which is 35. So the terms which are common to these two series, they are 17, and then 17 plus 35, 52, 52 plus 35, 87. Now we need that term which is of the form 1 plus 3p. That means from these numbers, we have to find that first number which, when divided by 3, leaves a remainder 1. Now when 17 is divided by 3, it leaves the remainder 2. So 17 is not our common term. If we look at 52, now we know that 17 into 3 is 51 and plus 1. So basically this 52 is 17 into 3 plus 1. So this is our first term which is common to all the three APs. So that means value of A is 52. Now we have A and we have D. We need to find the value of A plus D. So A plus D will be 105 plus 52, and it will be simply 157, which is the answer to this question. Now the question is, the largest term common to the sequence is 1, 11, 21, 31 up to 100 terms and 31, 36, 41, 46 up to 100 terms is. Now there are many ways to solve this question. We'll solve this question in two ways. Now first method is, we know that any general term for this first series can be written as 1 plus n minus 1 into d. So it will be 1 plus n minus 1 into 10, and we need common terms. So it will be equal to general term of this second series, which is 31 plus n minus 1 into 5. Now this is 10n minus 9, and this is 5m plus 26. I will take this 9 here, so it will be this 10n, that is 5m plus 35. We can cancel 5, so we can write 2n, and it will be equal to m plus 7. So this n will be equal to m plus 7 by 2. So the terms which are common to this series, they must have this criterion that this n must be equal to m plus 7. Now since m and n, they are positive integers, that means this m, it must be an odd number. Now we need largest term common to both the sequences. Now we need largest term. So highest odd value of m will be 99. In that case, value of n will be 99 plus 7, 106 divided by 2. So it will be 53. So the largest term which is common to both the series will be 1 plus n minus 1 into 10. For it, we'll put n is 53. So it will be 53 minus 1, 520. So it will be 521. We could have done it with m also. If we put m as 99 here, we can write this as 31 plus 98 into 5. Now this is 490 plus 31, which again is 521. And that is the option D, none of these. Now, second method of solving this question is, we have this theory that if we have two APs whose common differences are D1 and D2, then terms common to both the APs, there'll also be an AP whose common difference will be LCM of common differences of these two series. So in this case, the terms which are common, they'll form an AP, and common difference of that AP will be LCM of, now here common difference is 10, and for the second one common difference is 5. So the value of D, which is an AP, will be 10. Now the first common term in both the sequences, 31. So the terms which are common to both the series will form an AP with first term 31 and common difference of 10. Now if we write its general term Tn will be 31 plus n minus 1 into 10, and this Tn, it must be less than or equal to minimum of highest term of both the series. Now in this, last term of the second series will be less than last term of this first series. So last term of this second series is 31 plus 99 into 5, and it will be 526. So it should be less than 526. Now if we simplify this, we can write n is less than or equal to 526 minus 31 divided by 10 plus 1. So n should be less than or equal to 50.5. That means highest value of n will be 50. And if we put n as 50, we'll get this term as 31 plus 49 into 10, 490 plus 31, and that will be 521. So this is second method of solving the same question. Now the question is, in an AP, as P is Q and as Q is P, then we need to find as P plus Q. Now as P is P by 2, 2A plus P minus 1 into D, and this is equal to Q, and SQ is Q by 2, 2A plus Q minus 1D, and it is equal to P. Now what we'll do is we'll subtract second from first. Now we can write P minus Q into A plus p square minus p minus q square minus qd, and then we also have this 1 by 2, so it will be this whole divided by 2 and it will be equal to q minus p. Now this is p minus qa. We can rewrite this as p square minus q square minus p minus q d by 2, and it is equal to q minus p. Now we can cancel p minus q, so we can write a plus, this is p plus q minus 1 into d by 2, and this is minus 1, or we can write 2a plus p plus q minus 1 into d, it is equal to minus 2, and that's our first result. Now it says we need to find sum of p plus q terms. Now this is p plus q by 2 and 2a plus p plus q minus 1 into d. Now we know that 2a plus p plus q minus 1d is nothing but minus 2. So this sum will be nothing but minus p plus q, and that's your option B. Now here the question is 10th common term between the series is. So we are given 2 APs, 3, 7, 11 and 1, 6, 11. Now we know that terms common to both the series, they'll also be an 8 with common difference equals LCM of common difference of the two series. Here common difference is 4 and here common difference is 5. So the common difference of this resulting AP will be LCM of 4 and 5, and that will be simply 20. Now first term which is common to both the series is 11. We need to find 10th term of the series. So 10th common term to this series will be A plus 9 into 20, 180 plus 11, and that will be 191, and that's your option A. Now here the question is sides of a right angle triangle are in AP. If this triangle has area 24, what is the length of the smallest side? Now suppose we have this right angle triangle whose sides are in AP. So suppose sides are A minus D, A and A plus D, and where D is greater than 0. So from Pythagoras theorem we can write A plus D square, it is equal to A square plus A minus D square. So from here we can write A square equals 4AD or A equals 4T, and that's our first result. Now we look at area of this triangle. Area of this triangle is half A minus D, and it is equal to 24. Now A is equal to 4D, so there will be 2D into 3D equals 24. So D square is 4, value of D is 2, and if value of D is 2, value of A is 8. Now it says length of its smallest side. Now length of its smallest side is A minus D, which is 6, and that is the answer to this question. Now in this question it says let L1, L2 and L100 be consecutive terms of an AP with common difference D1, and W1, W2, W100 be consecutive terms of another AP with common difference of D2, where D1 into D2 is 10. Now for each I equals 1 to 100, let Ri be the rectangle with length Li and width Wi and area Ai. Now if A51 minus A50 is 1000, then find the value of A100 minus A90. Now for this Ri, if we consider Li will be L1 plus I minus 1 D1, and Wi will be W1 plus I minus 1 D2. Now we multiply it, we'll get AI. So basically AI will be L1 W1 plus I minus 1 L1 D2 plus D1 W1 plus I minus 1 whole square into D1 D2. Now we know that D1 D2 is 10. So we can write this AI as L1 W1 plus I minus 1 L1 D2 plus D1 W1 plus I minus 1 whole square into 10. Now first we are given that A51 minus A50 is 1000. A51 minus A50. Now for A51 we'll put IS51, so it will be this L1 W1 plus 50 L1 D2 plus D1 W1 plus 50 square into 10 and then minus A50. A50 will be L1 W1 minus 49 L1 D2 plus D1 W1 minus, and this is 49 square into 10 and this is equal to 1000. Now L1 W1 will cancel. Now 50 minus 49 is 1, so it will be this L1 D2 plus D1 W1 and plus, now here we'll take 10 common and this is A square minus B square, which is A plus B into A minus B. So it will be this 10 into 99 and this is equal to 1000. Now 1000 minus 990 is 10. So from here we'll get L1 D2 plus D1 W1 will be equal to 10. Now we need to find the value of A100 minus A90. So we need to find the value of A100 minus A90. Now A100 is L1 W1 plus 99 L1 D2 D1 W1 plus 99 square into 10 and then minus L1 W1. Now here it is minus 90 minus 1 is 89 L1 D2 D1 W1 minus, now I minus 1 square, I here is 90, so it will be this 89 square into 10. Now this L1 W1 will cancel and here this is 10 times L1 D2 plus D1 W1 and here we'll take this 10 common and this is 99 square minus 89 square. Now L1 D2 plus D1 W1 is 10, so it will be simply 100 plus 10. Now this is A plus B into A minus B. Now A minus B is 10 and A plus B is 188. So its value will be 18900 and that is the answer to this question.
Now here the question is, suppose that all the terms of an AP are natural numbers. If the ratio of sum of first 7 terms to the sum of first 11 terms is 6 by 11 and 7th term lies in between 130 and 140, then common difference of this AP is, it is an AP and it says ratio of sum of first 7 terms to first 11 terms, it is 6 by 11. So it means 7 by 2 twice A plus 6D upon 11 by 2 2A plus 10D, it is equal to 6 by 11. Now this 2 and 2 will cancel, this 11 will also cancel, so we'll get 14A plus 42D, this is 12A plus 60D, so we'll get 2a equals 18d, or value of a is equal to 9d. So this is our first relation. Now it also says the seventh term lies in between 130 and 140. So its seventh term will be a plus 6d will lie between 130 and 140. Now a is 9d, so we can write 130 is less than 15d is less than 140. So if we divide with 15, we can write 8.67 will be less than d, that is less than 140 divided by 15, which is 9.33. Now since all the terms they are natural numbers, that means this d, it should also be a natural number. So the only value of d possible here is 9. So we'll have value of d as 9, value of a is 81. We just need to find the common difference. So common difference of this AP is 9. And that is the answer to this question.
Now here the question is, let's Sn be sum of first n terms of an AP if S3n is equal to 3 times S2n, then the value of S4n upon S2n is. Now S3n is 3n by 2 twice a plus 3n minus 1 into d, and this is 3 times 2n by 2 into twice a plus 2n minus 1 into d. Now this 3n will cancel, this 2 will also cancel, we'll get this as twice a plus 3n minus 1 into d, and it will be equal to 4a plus 4n minus 2d. If we take everything on the right hand side, we can write 2a plus n minus 1d, and it will be equal to 0. So this is our result. Now we need to find the value of S4n upon S2n. So we need to find S4n by S2n. S4n is 4n by 2 twice a plus 4n minus 1d, and this is 2n by 2 twice a plus 2n minus 1d. Now here we'll get 2, so it'll be this 2, and we can write 2a as minus n minus 1d. So if we write minus n minus 1d, we'll get this as 3nd upon, and here we'll get this as n into d. Now n into d will cancel, so value of this ratio is 6. So answer to this question is simply 6. Here the question is, if A1, A2, A3, A100 be an AP with A1 equals 3, SP is sum of P terms, and it says if M is equal to 5n, if Sm by Sn does not depend on n, then the value of A2 is. Now we need to find this ratio Sm by Sn, and m in this case is 5n, so we can write 5n by 2 twice a plus 5n minus 1 into d, and this is n by 2 twice a plus n minus 1 into d. Now n by 2 will cancel, so we'll get this as 5 into 2a plus 5n minus 1 into d upon twice a plus n minus 1 into d. Now it says this ratio, it does not depend on n. Now this ratio will not depend on n in two ways. Now we have this first case when the value of d is 0. If the value of d is 0, these terms containing n, they'll become 0. We'll get this ratio Sm by Sn as simply 5. Now since d is 0, A2 will be equal to A1, which is simply 3. And we also have the second case where we can write this ratio Sm by Sn as 5 into now 2a minus d plus 5nd upon 2a minus d plus n into d, and we can put this 2a minus d equals 0. So if 2a minus d is 0, we'll get this as 25. So again, it'll be independent of n. So second condition we'll have is when the value of d is 2a and a in this case is 3. So when the value of d is 6, so in this case, a2 will be simply 9. So this second term will be either 3 or 9 or both. Now the question is, we are given these numbers a1, a2, a3 and a11 such that a1 is 15 and a2 is less than 27 by 2, which is 13.5, and it says ak it is equal to 2 times ak minus 1 minus ak minus 2, which is nothing but condition of an AP. So 2ak minus 1, it is equal to ak plus ak minus 2. So basically these terms a1, a2, a11, they are terms of an AP. Now it says if this summation AR square, where R varies from 1 to 11 by 11, it is 90, then find the value of summation AR by 11. Now we know that term of an AP is A, which is 15, plus R minus 1, and D we do not know. So this square whole divided by 11 will be equal to 90. Now if we expand this square, we can write this is 225 plus r minus 1 square into d square plus 30 r minus 1 into d whole divided by 11, and this is equal to 90. We'll take 1 by 11 common, and then we'll have this summation r varies from 1 to 11, 225, plus we'll take d square out, it will be this summation r varies from 1 to 11, r minus 1 square, plus we'll take 30d out, and then it will be this summation r varies from 1 to 11, r minus 1, and this is equal to 90. So it will be this 1 by 11, and this is 225 into 11, and this is d square. Now if you put r as 1, it will be this 0 square plus 1 square up to 10 square. So this is 1 square plus 2 square up to 10 square, and this is 30d, and here if you put r as 1, it will be 0. 0 plus 1 plus 2 up to 10. So this is sum of first 10 natural numbers, and this is equal to 90. Now we already know these formulas, so we can write 1 by 11, and this is 225 into 11, and this is d square, and this is n plus 1, 2n plus 1 by 6, plus 30d, and this is n plus 1 by 2, and this is equal to 90. Now this 11 will cancel. Now this is 5, and this is 5 and 7. So we'll get this as 225 plus 35d square plus 150d, it is equal to 90, or 7d square plus 30d plus 45 minus 18 equals 0. So we'll get this quadratic result in D, which is 7d square plus 30d plus 27 equals 0. Now this is 7d square plus 21d plus 9d plus 27 equals 0. So we can write 7d plus 9 into d plus 3 equals to 0. So value of d is either 9 by 7 or value of d is minus 3. So here The two possible values of D are either minus 9 by 7 or ds minus 3. Now if we take ds minus 9 by 7, our second term, it won't be less than 13.5. So we'll discard this. So the only value of d possible here is d equals minus 3. So for this AP, first term is 15 and common difference is minus 3. Now we need to find A1 plus A2 plus A11 by 11. Now this is sum of first 11 terms. So this is 11 by 2 twice A plus 11 minus 1 into D. Whole divided by 11. Now this is 30 minus 30 is 0. So answer to this value is 0. Now here the question is, if A, B, C are in AP, then we need to find the value of A square B plus C plus B square C plus A and C square A plus B. Now there are two ways to solve this. Now one of the ways is, if A, B, C are in AP, we can choose them as B minus D, B and B plus D. So this expression A square B plus C plus B square C plus A plus C square A plus B will be equal to B minus D whole square, and B plus C will be 2B plus D plus B square. Now C plus A will be 2B and plus B plus D square and will be 2B minus D. Now we'll take 2B terms together. So it will be 2B and this is B minus D square plus B plus D square. We'll take terms of D together. So it will be this D and it will be this B minus D square minus B plus D square, and then it will be this twice B cube. Now here 2BD will cancel. So it will be this 2B B square plus D square plus B square plus D square. So it will be into 2 and plus D. Now here B square D square will cancel. So it will be this minus 4BD and plus 2B cube. Now this is 4B cube plus 4BD square minus 4BD square plus 2B cube. Now it will cancel. So this is 6B cube. Now we know that twice B equals A plus C, or 3B equals A plus B plus C, or B is simply A plus B plus C by 3. So it will be this 6 A plus B plus C by 3, which is 2 by 9 A plus B plus C, and that's your option B. So this is one way of solving it. Now another way to solve this question is, we know ABC are in AP and we also know A square B plus C, B square C plus A and C square A plus B, they are also in AP, and we can prove this also. So if we take their difference, so this difference will be B square C plus A minus A square B plus C. We'll take terms of AB together. So we'll take AB common, and then it will be this B minus A plus, and then we'll take C common, it will be B square minus A square. Let's call this difference as capital D. So here we can take B minus A common, and it will be this AB plus C, and this is B plus A. Now B minus A is nothing but common difference of an AP, say D, and be AB plus BC plus CA. So it is symmetric in ABC. So clearly, if we look at this other difference, C square A plus B minus B square C plus A, will also be this D into AB plus BC plus CA. So basically, it proves that these three numbers, they'll be in AP. So if these three numbers, they are in AP, then A square B plus C plus B square C plus A plus C square A plus B. Now this is twice b equals a plus c. So we can write a plus c as 2b. So there'll be simply 3b square c plus a. Now c plus a is 2b. So there'll be 6b cube, which is the same result. Now we already know a plus b plus c is 3b. So it'll be this 2 by 9 a plus b plus c whole cube, which again is your option B. Now the question is, let VR denotes sum of first R terms of an AP whose first term is R and common difference is 2R minus 1. So we can write this VR as R by 2 twice A. So 2R plus R minus 1 into D, which is 2R minus 1. So it'll be this R by 2 and this is 2R plus 2R square minus 3R plus 1. So this VR will be basically R by 2 2R square minus R plus 1. Or we can write it is twice R cube minus R square plus R divided by 2. The first question is, we need to find sum of VR when R varies from 1 to n. So for this first part, we need to find this summation R varies from 1 to n VR. So it will be simply this summation R cube minus 1 by 2 summation R square plus 1 by 2 summation R. Now this is n plus 1 by 2 square. This is 1 by 2 n plus 1 2n plus 1 divided by 6, and this is 1 by 2 n plus 1 by 2. Now we can take n plus 1 by 4 common. So we'll take n plus 1 by 4 common. We'll have n plus 1 minus 2n plus 1 by 3 plus 1. So it will be this n plus 1, and we'll have 3n square plus 3n minus 2n plus n, and then it will be minus 1 plus 3 plus 2 whole divided by 4 into 3, 12. And that's your option B. Now for the second part, we need to find TR, and TR is VR plus 1 minus VR minus 2. So basically this TR will be VR plus 1, and VR plus 1 will be 2R plus 1 cube minus R plus 1 square plus R plus 1 by 2 minus 2R cube minus R square plus R by 2, and then minus 2. Now we'll take these terms together. So we can write TR as R plus 1 cube minus R cube, and then minus 1 by 2 R plus 1 square minus R square, and then plus 1 by 2 R plus 1 minus R will be simply 1, and then minus 2. Now this is A cube minus B cube. So it will be A minus B, and then A square plus B square plus AB. So it will be R plus 1 square plus R square plus R into R plus 1. Here again it will be A plus B into A minus B. So it will be 1 by 2 2R plus 1, and it will be minus 3 by 2. So we can write this TR as 3R square plus 2R plus R, 3R plus 1, and then minus R, and this is minus 1 by 2 minus 3 by 2. So there will be minus 2. So we can write this as 3R square plus 2R minus 1, or it will be 3R square plus 3R minus R minus 1. So we can write this as 3R minus 1 into R plus 1, which is the product of two factors. So it is a composite number. So that means 48 is D. And then finally, we need to find statement about Q1, Q2, Q3, QR, and QR is TR plus 1 minus TR. Now we already know TR is R plus 1 into 3R minus 1. So TR plus 1 will be R plus 2, and here will be 3R plus 2 minus, and this is R plus 1 into 3R minus 1. So it will be this 3R square plus 8R plus 6 minus, and this is 3R square plus 2R minus 1, which is 6R plus 5. So basically this QR, it is a linear function of R. So that means this QR, they will be in AP. So Q1, Q2, Q3, they are in AP, and their common difference should be 6. This should be your option B. So the correct options are B, D, and B. Now here the questions. We are given a sequence of numbers A1, A2 up to A1005 which satisfy A1 upon A1 plus 1 equals A2 upon A2 plus 3 equals A3 upon A3 plus 5 equals A1005 upon A1005 plus 2009. And we are also given that A1 plus A2 plus A3 up to A1005 is 2010. We need to find the nature of this sequence. Now, since they are equal, let us write, suppose it is equal to 1 by k. So, for any AR, we can write AR upon AR plus 2R minus 1, it is equal to 1 by k, or AR k minus 1 equals 2R minus 1. So this AR will be 2R minus 1 upon k minus 1, where this k minus 1 is constant, and this 2R minus 1, it is nothing but an AP. So nature of this sequence is an arithmetic progression. Now if we look at this sum, which is A1 plus A2 plus A 1005, and this is 2010. So it is summation 2R minus 1, where R varies from 1 to 1005 upon k minus 1, and this is equal to 2010. Now sum of first odd natural numbers is equal to n square. So it will be equal to 1005 whole square, and this is equal to 2010 into k minus 1. Now if we cancel this, it will be simply 2, or k will be 1 plus 1005 by 2, or 1007 divided by 2. Now we need to find 21st term of the sequence. So we need to write A21, and A21 will be 41 upon k minus 1, and that will be 1005 into 2, which is 82 upon 1005. So answer to this question is, the sequence is an AP and whose 21st term is 82 upon 1005. Now the question is, if the sum of roots of the equation ax square plus bx plus c equals to 0 is equal to the sum of squares of their reciprocals, then find whether b square, c square and ab square are in AP, GP or HP. Now what we are given is sum of roots. That means alpha plus beta is equal to sum of squares of their reciprocals. That means 1 upon alpha square plus 1 upon beta square. So essentially it is alpha plus beta, and it is alpha square plus beta square upon alpha square beta square, which we can also write as alpha plus beta whole square minus 2 alpha beta upon alpha square beta square. Now alpha plus beta is minus b upon a. This is minus b upon a square minus 2c upon a, and this is c square upon a square
we can write as minus b upon a, and here it will be b square minus 2ac upon c square, which we can write minus bc square equals ab square minus 2a square c, or 2 times a square c equals ab square plus bc square, which means these three given numbers, they are in AP, and that is the answer to this question. Now here the question is, we are given this quadratic equation in which we have x square plus x plus 1 plus x square plus 2x plus 3, x square plus 3x plus 5 up to x square plus 20x plus 39, and is equal to 4500. Then the value of x is equal to what? Now we have 20 factors. So if we take x square, there will be 20x square plus, and what is the coefficient of x? It is 1 plus 2 plus 3 up to 20. So there will be 1 plus 2 plus 3 up to 20x, and then we have 1 plus 3 plus 5 up to 39, and this is equal to 4500. Now this is 20x square. Now this is n plus 1 by 2 x, and this is sum of first 20 odd natural numbers, and it is equal to n square. That will be equal to 20 square, and this is 4500. Now this 20, 20 and 20 will cancel. So this is 225. If we multiply this 2, we'll get this as 2x square plus 21x, and this is 40, and this is 450. So it will be minus 410 equals 0. Now we can write this as 2x square plus 41x minus 20x minus 410 equals 0. So this is 2x, x plus 41, and this is minus 20, x plus 41 equals 0. So value of x is either 10 or value of x is minus 41. So in this case, the only possible value of x is plus 10, and that's your option A. Now the question is, let A1, A2, A3, An be real numbers in AP such that A1 is 15 and A2 is an integer, and we are given that sum of squares of first 10 numbers is 1185, and if Sn is r varies from 1 to n and maximum value of n is n, for which Sn is greater than Sn minus 1, find the value of n minus 10. Now we are given that A1 is 15, and we are also given that summation AR square, where r varies from 1 to 10, it is 1185. Now its general term will be 15 plus r minus 1d whole square, and this is 1185. Now we can write this as summation r varies from 1 to 10, 225 plus r minus 1 square into d square plus 30 r minus 1 into d, and this is 1185. Now we take this summation. This first term will be 2250. Now this is 0 square plus 1 square up to 9 square. So this is 1 square plus 2 square up to 9 square d square, and this is 30, and this is 0 plus 1. So it is 1 plus 2 up to 9 into d, and this is 1185. Now this is n plus 1, 2n plus 1 by 6. So this is 9 into 10, 19 by 6 d square, plus this is 30, and this is n plus 1 by 2 into d, and plus this is 2250 minus 1185, which is 1065 equals 0. Now this is
3, this is 5, this is 5. Now we'll divide everything with 15. This is 71. So we'll get this equation as 19d square plus 90d plus 71 equals 0. So we can write this as 19d square plus 19d plus 71d plus 71 equals 0, or 19d plus 71 into d plus 1 equals 0. So value of d is either minus 71 by 19 or value of d is minus 1. Now it says a2 is an integer. So if a2 is an integer, that means we cannot take d as minus 71 by 19. So the only possible value of d here is minus 1. So for this arithmetic progression, a1 is 15 and common difference is minus 1. We need to find the condition that Sn is greater than or equal to Sn minus 1. Now Sn is t1 plus t2 up to tn, and this is t1 plus t2 up to tn minus 1. That means this tn, it should be greater than or equal to 0. So we need to find maximum value of n for which tn is greater than or equal to 0. Now tn is 15 plus n minus 1 into d. It is greater than or equal to 0, or n minus 1 is less than or equal to 15, or n is less than or equal to 16. So the greatest value of n is 16, and n minus 10, it is nothing but 6. Now here the question is, let a1, a2, a3 up to an be an AP with common difference d, and we have defined bk as the series ak plus ak plus 1 up to ak plus n minus 1. Now this series, it goes from 0 to n minus 1. So number of terms in this series is simply n. So bk basically is sum of n terms of this series. We can write this as n by 2, and it will be ak plus n minus 1. Now this is n minus 2. Now ak is kth term, so it will be a1 plus k minus 1d, and this ak n minus 1 will be a1 plus k plus n minus 2d. Now we can take k minus 1d and k minus 1d here, so it will be this n by 2 a1 plus, we also have this a1, and then 2 times k minus 1d, and what we are left with is n minus 1d. Now a1 plus n minus 1d is nothing but an. So we can write this as n by 2 a1 plus an plus 2 k minus 1 into d, which is your option C. So that's your option C. Now we'll also need to find summation bk. So that's your bk, and we need to find summation bk where k varies from 1 to n. Now if we take this summation, we can write this summation bk as, now it is n by 2 a1 plus an into n, since it is a constant term, plus, and then we'll multiply this n by 2, so we'll have this n d, and then summation k minus 1 where k varies from 1 to n, so it will be this n square by 2 a1 plus an, and here will be this nd, and this series is 0 plus 1 up to n minus 1, which is n minus 1 n by 2. What we'll do is we'll take n square by 2 common, and then we'll have a1 plus an plus n minus 1d. Now a1 plus n minus 1d again is an, so there will be n square by 2 into 2an. So summation bk will be simply n square an, and that's your option A. So the correct options are A and C. Now here the question is, if A1, A2 up to A21 are in AP and sum of this AP is 693 and sum of odd terms of this AP is 5k plus L, then k plus L upon 25 equals to what? Now we know that A1 plus A2 plus A3 up to A21, it is equal to 693. Now we also know that its middle term, it will be 21 plus 1 divided by 2, and that is 11th term. So A1 plus A21 by 2 equals A2 plus A20 by 2, and it will be equal to A11. We can make these pairs. So we'll form 10 pairs of A1 plus A21, and that will be equal to 2 times A11 plus A11, and that is equal to 693. So we'll get 21 into A11 equals 693. So value of A11 is 33. Now we need to find sum of this series. A1 plus A3 plus A5 up to A21. So here we have 11 terms, and middle term will be its 6th term, which again is A11. So it will be 5 times A1 plus A21 plus A11, and this is 2 times A11, so there will be 11 times A11, and that is 363. Now we divided 5, it will be 35, 2, so we can write this as 72 into 5 plus 3. We have expressed it in the form 5k plus L, where the value of k is 72 and value of L is 3. Now it is asking for value of k plus L upon 25. So there will be 75 upon 25, 3. So answer to this question is simply 3. Now here the question is, the balls are arranged in row to form an equilateral triangle. The first row contains 1 ball, second row contains 2 balls, the third row 3 balls, so on and so forth. So for any nth row will contain n balls. Now here we have formed an equilateral triangle. Now it says, if we add 669 balls, then we can form a square and each of its sides that contain 8 balls less than each side of the triangle did. So if there are n balls in the sides of a triangle, in this square there will be n minus 8 balls in any one side. Now first we'll count total number of balls in this equilateral triangle. So it will be this 1 plus 2 plus 3 up to n, and then we are adding 669 balls, and then number of balls in this square will be simply n minus 8 square. Now this is n plus 1 by 2 plus 669, and this is equal to n square plus 64 minus 16n, or we can write n square plus n plus 669 minus 64. 605 into 2, 1210, and there will be 2n square minus 32n, or we can write n square minus 33n minus 1210 equals 0. Now this is 11 into 11 into 10. Now this is 5 into 2, 55 minus 22. So we can write n square minus 55n plus 22n minus 1210 equals 0. So from here, the value of n we get is 55. So n equals 55. So number of balls in the sides of an equilateral triangle will be 65. So this C matches with P. Now number of balls inside of square is n minus 8. Now 55 minus 8 is 47. So this D, it matches with S. Now initial number of balls is n plus 1 by 2. So it will be 55 into 56 by 2. So this is 28, which is 14 into 110, so which is 1540. So this A, it matches with Q. And number of rows forming the equilateral triangle, now number of rows is again equal to n, and which is 55. So this also matches with P. And that is the answer to this question. Now the question is, a child was asked to add the first few natural numbers, that is 1 plus 2 up to 3, so long as his patience permitted. When he stopped, he gave the sum 575. When the teacher declared the result wrong, the child discovered that he had missed one number in the sequence during addition. The number he missed was. Now if the child has added all the numbers from 1 to n, its sum would have been n plus 1 by 2, and suppose the number he has left out is A, and this sum is now 575. So what we'll do is, rather than finding this A, we'll find a number which is closer to 575. Now this is n square plus n minus 1150 equals 0. So the value of n which is closer to this sum, it will be minus 1, we'll take plus sign, and then it will be 1 plus 4 into 1150 whole divided by 2. Now 1150 into 4, it is 4600 plus 1. Now under root of this value is 0.678, so it will be nearly minus 1 plus 67.8 divided by 2, which is nearly 33.4. Now this A is n plus 1 by 2 minus 575. When n is nearly 33.4, the value of A is 0. Now this A, it must be positive. So the value of n that we need to take is the integer which is greater than 33.4. So we'll take n as 34, and if we take n as 34, it will be 17 into 35 minus 575, and which is 20. So the number that was missed by the child is number 20, and that's your option 3. Now here the question is, in the sequence 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, where n consecutive terms have the value n, then 1/50th term is. Now suppose this is series of n minus 1, it ends here, and then we have series of n, and then we'll have series of n plus 1. And suppose 1/50th term, it lies in this series of n So we need to find the value of n. Now here we have one term, here we have two terms, here we have three terms, and here we'll have n minus 1 terms. So number of terms from 1 to n minus 1 will be simply n minus 1 n by 2. So this 150, it must be greater than n into n minus 1 by 2, and it should be less than or equal to number of terms from 1 to n terms. So it will be less than n into n plus 1 by 2. Now basically n into n minus 1 should be less than 300, which should be less than or equal to n into n plus 1. Now we know that 16 into 17, it is 272. We need two consecutive terms, and 17 into 18, it is 306. So that means value of n, it must be 17, and that's your option A. Now if the question is ABC is a right angle triangle in which angle B is 90 and BC is A. So we have a right angle triangle ABC in which angle B is 90 and the side BC, it is equal to A. If n points L1, L2, Ln are taken on AB are such that AB is divided in n plus 1 equal parts. So we have taken n points on this line AB. So we have L1, L2, Ln, and the same way we have taken M1, M2 and Mn on AC such that L1, M1, L2, M2, Ln, Mn are line segment parallel to BC. So all these lines, they are parallel to BC. That means they will also form this right angle triangle. Now suppose this length is C and this length is B. Now there are n points and this AB is divided into n plus 1 part. So basically AL1, it is C upon n plus 1. AL2 is 2C upon n plus 1, and ALR will be equal to RC upon n plus 1. In the same way, AM1 will be B upon n plus 1. Again, it is divided into n plus 1 parts. AM2 is 2B upon n plus 1, and AMR will be RB upon n plus 1. Now, if we look at this line LR, MR, then we can write LR, MR square will be equal to AMR square minus ALR square. Now AMR square, it will be R square B square upon n plus 1 square minus ALR square will be R square C square upon n plus 1 square. So we can write LR MR square, it will be B square minus C square upon n plus 1 whole square into R square. Now B square minus C square is nothing but A square. So this length LR into MR will be simply A upon n plus 1 into r. Now we need to find sum of all these lengths. So we need this summation where r varies from 1 to m, lr, mr. So it will be this a upon n plus 1, and then this summation r where r varies from 1 to n. So it will be this a, n plus 1, and here will be n plus 1 by 2. Now n plus 1 by 2 will cancel. So sum of all these lengths will be equal to a n by 2, and that's your option C.